Hi everyone, so welcome to this video. So in this video we're gonna be solving a combination problem. So here is the problem statement. So basically we'll be given the head of a single linked list and we have to write an algorithm which returns the middle node of the given linked list. Yeah. So, however, if we have even number of nodes in our linked list, we'll have two middle nodes, right? So, in that case, we have to return the second one. So, while in the case of odd number of nodes in the linked list, we'll have only one middle node, right? So, we have to return that. So, if we see these three examples, in the first example, we can see we have five nodes. So, we'll have only one middle node, so which is the node with value 3. So, we have to return that output. So, in the second example, we have a linked list with six nodes. So, over here, the middle nodes are the nodes with value 3 and 4. So as we said, we have to return the second one of the middle node, which is the node with value 4. So in the third example, we have two nodes. So we have an even number of nodes. So we can say that one is the first one of the middle node and two is the second one of the middle node. So we have to return the node with value 2 as the output. Yeah, so this is the problem statement. Now we'll be solving this problem in two approaches. So in the first approach, basically the idea of first approach is since we have to find the middle node of the linked list, right? So if we know the position of the middle node, we can basically traverse that length in the link through the linked list and find that get that relevant node, right? Yeah, so this is the idea of this. So for that, basically first we have to find number of linked list, number of nodes in the linked list. So first we have to write a function to get the number of nodes in the linked list, or else we can say the length of linked list. And then we'll be traversing that length if the number of nodes is n by 2. So we'll be traversing n by 2 length in the given linked list from the start or from the head node, and we'll be getting the relevant middle node of the linked list. So this is the idea of this approach. So over here, since if we assume that n is the number of nodes in a given linked list, then uh, n by 2 will basically give the position just before the middle node if n is odd. So in the case if n is even, n by 2 will give the position of first one of the middle nodes. So even if n is odd or even, we have to get the node whose position is n by 2 plus 1 from the start. So in case of n is odd, we'll get the middle node. In case of n is even, the n by 2 plus 1 node will give the second one of the middle nodes. Yeah, so this is what we have to do. We have to first get the number of nodes in the given linked list. If we assume it as n, then we have to traverse a length of n by 2 plus 1 from the start, and so that will be stopping at the our relevant node, which is the middle node. Yeah. So this is the computer program of the algorithm which we have discussed. So this is basically written in Java. So this is the main core method of our algorithm, whose name is middle node. So which basically takes the parameter as linked list node. So which basically takes the head node of the linked list. So over here, first we'll be calling the length method. So in length method, we can see I have written a loop. I have been looping this head so that we'll be traveling across the linked list, and I am incrementing the integer called I, which is start basically initialized as 0, so that we'll get the length of the linked list. Yeah, so this is how the length will be calculated, and then I'm assigning this length by 2 value to this variable called n, and then I have been traversing here I have been starting from I equal to 0 all the way to n minus 1. So I have been making iterations of n plus n iterations. So I have been doing n iterations. So n I have been traversing the linked list from the head node. So since I have been traversing a length of n, and using the head, already we have been in head, right? So if we traverse n length, we'll be in the n plus 1th node. We at the end of this loop, we'll be end up in the n plus 1th node. So since n is length by 2, so we'll be basically end up at the length by 2 plus 1th node, so which is the node which we want. So we'll be returning it. So this is the computer program of the algorithm which we have discussed. So if you examine the time complexity of this algorithm, so basically in the if you examine this main method middle node, so over here first we are calling the length method. So this length method, basic in this length method, basically we are traversing all the nodes of the given linked list. So basically it will have a time complexity of big O of n. So where n is the length of the linked list, or we can say the number of nodes in the linked list. And after that we have been again looping through the linked list half the length of linked list times. So if I assume the length is n by n, so we have been iterating n by 2 times basically. So putting all together, we can say that the time complexity is in the order of n. So we can say the time complexity is big O of n. Now, if we examine space complexity, so over here we can see that we have not creating any data structures and populating it. So we can say that space complexity is constant. Yeah, so this is about first approach where we have first calculated the number of nodes in the given linked list, and then using that we have been traversing the linked list and getting the relevant node, which is the middle node in our case. Yeah, now let us go to second approach, which is using fast and slow pointers technique. So basically, this fast and slow pointers technique is mainly used in problems such as where we have to find, have to determine whether there is any loop or cycle existing in a linked list or any linear data structure, and also in problems such as where we have to find the specific elements in a linear data structure. Specific elements, especially I mean the elements which basically divides the given sequence into quantiles. So in our case over here we have to find the element which is basically dividing our linked list into halves. Yeah, so in this type of problem we'll be using this fast and slow pointers in general. So in this approach, basically first we'll be initializing two nodes to let us name it as slow and fast node. So both will be initialized as head, which is the given input to our algorithm, and we'll be incrementing this slow node one step at a time, and we'll be moving the fast node two steps at a time. Yeah, and at the end the fast node will basically stop with the either, as we are incrementing fast node two steps at a time, so basically it can stop at two positions. Either it can stop at the last node, or it will stop at the null crossing the last node. Yeah, so it crosses, even it stops at last node, or even if it crosses last node and becomes null, the slow pointer will give the relevant will be pointing to the relevant node, which is the middle node. So basically when fast pointer is at the last, the slow pointer will be pointing to the middle node, since we have been moving the fast node two steps at a time and slow node one step at a time. Yeah, so if we go into in detail, so since I have been saying fast node can stop at two positions, one is at the last node, or it can stop at null crossing last node, since we have been incrementing fast node two times at a time, right? So basically this depends on the n. So if when n is even, the fast node will stop at the null crossing the last node. So when n is odd, the fast node will basically stop at last node. Yeah, so and also we can say when n is odd, as when fast node will stop at null, the slow node will stop at the second one of the middle node, since we have n even number of nodes, we'll have two middle nodes, right? So when n is even, fast node will stop at null, and slow node will stop at the second one of middle node. And when n is odd, the fast node will basically stop at last node, and slow node will stop at the middle node. Yeah, so basically we have to do either of these two checks. We have to iterating when fast node is either pointing to null, or fast node is pointing to the last node. Yeah, so this is what this algorithm is all about. So this is the computer program for this algorithm. So this is written in Java programming language. So over here we have this method called middle node, which basically takes the head node of a linked list as an input, and I have been initializing two list nodes, slow and fast, both are initialized as head, and I have been incrementing slow node one step at a time and fast for two steps at a time, and I have been doing this until fast is not equal to null and fast dot next is not equal to null. So this will basically check whether fast node is pointing to last node or not. When fast node is either pointing to last node, or if fast node stops at null, this will stop. Will be stop incrementing. And also here we have another conditional slow notification. Basically, this is not required at all because we are incrementing slow one step at a time, right? So before slow becomes null, the fast should have already become null, uh, right? So even if we don't have this, that's not a problem. And so that's and at the end of this loop, we'll be returning slow node. So since either when fast node points to last node, or if fast node crosses last node and points to null, the null node will be pointing to the relevant node, which is the middle node. So middle node in case of when n is even, and second of middle node when n is even. Yeah, so this is what is about the second approach, where we have been using two pointers to solve this problem. Here, one is a fast pointer and one is a slow pointer. So, if you examine the time complexity of this algorithm, so here the this while loop basically will be as long as the half of the number of nodes in the given linked list. So we can say the time complexity is in the order of n. So we can say the time complexity is big of n. The space complexity is constant, since we have not been populating any data structures and returning it. Yeah. So this is what all about this approach. So we have solved this problem in two approaches. Yeah. So I will link the link of this sheet I'm displaying over here in the description of this video. So feel free to check this out. Yeah. So that's it for this video. See you in the next.